I want to start by saying how excited I am to be here and how thrilled I am for the first ever all virtual DevOps Enterprise Summit. I miss seeing some of you in the hallways, but I'm very glad to be interacting with everyone via the Q&As, the virtual happy hours, and all the other great networking opportunities the organizers have planned. I'm monitoring the Q&A right now, so please, as I dive into this, send your questions over so we can keep this interactive.
So first, a bit about myself. I've been doing academic research in software analysis, security, and programming languages for more than 15 years. First, as part of my PhD work at Carnegie Mellon, and then at other universities and research labs since then. To give you an idea of the timeline, I still remember the first talks on the research that led to Coverity, which was founded almost 18 years ago. So I've seen a lot of change since then. I've been involved in this area for a long time. And lately, there have been particularly exciting changes happening at the largest tech companies in how they use program analysis tools, not just to find security issues, but to enhance developer productivity. And that's what I'm going to talk about now, is these approaches to enhancing productivity using advanced tooling. And this approach influences a lot of what we do at MuseDev, where we work to make this technology more accessible, but it's broader than any one company. And today, I want to talk about this general trend and the other places I see it cropping up, including at various companies here in the DevOps enterprise community. So what is this trend? It starts with a word we all love. I'm imagining the rush of dopamine, the warm smiles as the slide sinks in, right? Continuous. Because this is an ethos that we all believe in, right? This idea of continuous. But continuous what? Well, continuous everything. And what exactly is so magical about the ideal of continuous? Well, striving to do things continually has this effect of both improving outcomes and lessening pain. It's this, at first, counterintuitive concept that if there's something you're doing that's valuable but painful, then you should probably be doing it more frequently. And this frequency will cause it to become less painful because you'll find ways to automate it. You find ways to decrease friction. And so by aggressively automating a task and making its execution the concern of infrastructure, you free up humans to then focus on other things. And so we've seen this happen with continuous integration, where this painful process of combining components, building code, performing integration testing, this all becomes automated. And you reach the state where everything is just always working together. And it happens with continuous deployment, where standing up production infrastructure, rolling out code updates, switching over production traffic, all becomes automated. And the associated pain and risk in that process decreases significantly. And there's an emerging trend to apply this same sort of spirit of automation to assurance tasks. So I see it happening at the largest tech companies. I see it being explored in the government world. And I see it at various enterprises right here in the DevOps enterprise community. And this is what I'm going to be talking a lot about in this talk. But first, what do I mean by assurance? Well, broadly speaking, I mean quality, security, and compliance. And one interesting thing about this movement is that organizations that have started down this path, it's often one of these three that's the driver, but it quickly becomes about all three. And that's because at the end of the day, these goals are really very tightly coupled. So it's this continuous assurance process I'm going to be focusing on as a driver of new productivity gains. And I'm going to explore it by telling three stories. First, two from some large tech companies, Google and Facebook, and then one in the government world. And that one, it's a government-driven effort, but also there's community elements. And then I'm going to talk about what's happening in the broader community, in particular, the DevOps enterprise community right here. But let's start with Google and the work that they've done to decrease their pain. And the pain we're talking about in this case is static analysis. And what could be more painful than static analysis, right? You know, I'm sure we've all had situations where we fought with static analysis tools. And it's true, they can be painful when they're deployed badly. But what does it mean to deploy a tool badly or deploy it well? Well, there's a lot to learn from how Google has explored deploying these tools. So I want to start by telling a story of an experiment they did. So they had a new Java static analysis tool that they were bringing in. It had shown a lot of promise, found valuable errors in the test code that they'd run it on. And so they took this tool and tried to apply it to the code base as a whole. They actually organized a sort of hackathon, a week-long process where they had hundreds of Google engineers come together and try to address all of the findings that this tool surfaced. But it didn't go well, right? So even with hundreds of Google engineers working for a week, they got through less than half of the issues that were reported. And of those that they managed to go through and triage, less than a sixth of those were actually fixed. And it's because when you do it this way, when you're going through issues in code that you wrote a long time ago, code that engineers aren't familiar with, the bar is so high for how bad a bug has to have it be worth digging through that old code and remembering enough about what's going on to fix the error without breaking anything else. It's just very few issues that reach that point. And even if they had managed to go through all of the code and finish this process, Google has over 2 billion lines of code and 16,000 changes per day. And those are actually old numbers, so I'm sure it's way more now. So there's no way that a human-driven bug triage process can keep up with that level of change, right? And this should sound familiar, right? There's also no way that a batch mode human-driven process can keep up with the scale of modern systems development and deployment. And so we don't do this, right? We don't wait and integrate our systems just once a week or save building the full system for shortly before a release, right? We use continuous integration, we use continuous deployment. So why should we be doing that batch mode approach to static analysis? But it's often what companies do, right? This situation on this slide probably looks familiar to a lot of people here, where you set up a process that has developers on one side, sort of throwing code periodically over a fence to the security team on the other side. That team reviews the code, does testing, they apply SAST tools, DAST tools, send the results back over to developers. Developers never asked for these results in the first place, right? They just want to get their code out. They want to implement new features and keep pushing the product forward. And so not surprisingly, this doesn't go well, right? Developers start to see security as this gating process, this blocker in them getting their releases out. And security is frustrated too, right?